Welcome back to The Explainer. I am absolutely thrilled to have you here today because we are taking on a mission to demystify a really specific, honestly fascinating puzzle in economic cost analysis. We're looking at the precise relationship between production cost curves as a business scales up. If you've ever stared at an economics graph and wondered why certain lines behave exactly the way they do, well, you are in exactly the right place. Here is our quick roadmap for today. We'll hit 1, introduction to average costs, 2, the core behavior, 3, graph breakdown, and 4, the golden rule. Let's just dive right in. All right, section 1, introduction to average costs. Let's meet our 3 main characters. Before we look at the phenomenon itself, we need to quickly establish the cast. First up is average fixed cost, or AFC. Think of this as the per unit cost of your fixed obligations, things that don't care if you produce 1 item or a million, like the rent for your factory building. To find it, you literally just divide your total fixed cost by the total quantity of units you produced. Our second character is average variable cost, or AVC. Unlike your fixed costs, these are the expenses that bounce up and down directly with your level of output. Stuff like the raw materials you consume or wages paid to temporary workers. You calculate this one by dividing your total variable cost by the total units produced. And finally, we have average total cost, sometimes just called average cost or ATC. This is the big picture. It's the per unit cost of absolutely everything, both fixed and variable factors combined. You get this overarching metric by taking your grand total cost and dividing it by total units of output. So here is the absolute game changer, this simple mathematical reality. Average total cost is literally just the average variable cost plus the average fixed cost. Because your total costs are just made up of fixed and variable expenses, your per unit total is just those 2 per unit averages slapped together. This simple equation, it's the engine driving everything we're about to see. Moving right along to section 2, the core behavior, we're looking at a shrinking distance. Now that we've got our defining equation, let's look at a highly specific question. And by the way, this is a classic concept that often pops up for 2 or 3 marks on exams. As a firm's output increases, why on earth do the ATC and AVC curves get closer and closer together? What's the actual physical mechanism causing this gap to close as more items roll off the assembly line? Let's hit section 3, graph breakdown, where we visualize this closing gap. Let's translate that math directly into physical space. Here is your classic textbook graph mapping our 3 characters. Down on the horizontal x-axis, we have the volume of production. Up the vertical y-axis, we have the cost. You'll notice the U-shape of our ATC and AVC curves, but for now, I want you to focus entirely on the space between the top curve, ATC, and the middle curve, AVC. Specifically, zero in on the far left side of the graph. At these super early levels of output, right near the y-axis, the ATC curve sits pretty far above the AVC curve. Why? Well, at this early stage, that massive total fixed cost, like your factory rent, is only being divided by a handful of units. So naturally, the average fixed cost makes up a massive, massive percentage of your total per unit cost. Let's actually track this physical act of increasing production step by step to see exactly why these costs shift. Step 1, at low output, AFC is huge, propping the ATC curve way up. Step 2, as output grows, the magic happens. That same exact static fixed cost gets spread out over more and more units. Step 3, by the time we hit high output, the average fixed cost has been totally diluted, becoming a relatively tiny sliver of the total cost. And as you trace those lines to the right, heading toward higher levels of output, you can visibly see it happening. The ATC curve steadily drops down closer and closer to the AVC curve. Because that fixed overhead is continually diluted across a mountain of products, its influence basically shrinks. The gap between total cost per unit and variable cost per unit naturally tightens up. And this is where the graph just brilliantly illustrates our equation. Look closely at those vertical tracking arrows, squeezing between the 2 curves, literally labeled AFC. Since ATC equals AVC plus AFC, the physical vertical space between the ATC and AVC curves is exactly the average fixed cost. As AFC falls downwards on its own curve at the bottom, that vertical gap between the top 2 curves shrinks by the exact same amount. Which brings us to our final stop, section 4, the golden rule, the unbendable law of costs. This visual convergence creates a ton of tension. I mean, if the lines keep getting closer and closer together as output grows, do they ever cross? The definitive answer is anchored in this one single number, 0. This number represents what average fixed cost can never, ever become. Let me explain. Our textbook lays down this unbendable rule right here. ATC and AVC curves never meet each other because AFC is always positive and cannot fall to zero. Think about it. As long as a firm has literally one single dollar of fixed cost, dividing that positive number by any amount of output is always going to give you a fraction greater than zero. The AFC curve just kind of inches closer and closer to the x-axis, but never actually touches it. Because of that, this ever-present positive AFC acts like an invisible force field, keeping the ATC and AVC curves permanently mathematically apart. They can get incredibly close, but no way, they never touch. So this leaves us with a really interesting real-world question to ponder. Since we now know, mathematically and visually, that fixed costs never truly vanish to zero on a per-unit basis, how should this unbendable economic law influence a business leader's ultimate limit on scaling their operations? You know, you can dilute your overhead, but you can never totally erase it. Hopefully this explainer completely transformed how you see these cost curves. Keep questioning the graphs, keep visualizing the math, and we will catch you in the next explainer.